Hello everyone. Today we are going to discuss some problems related to haloalkanes and haloadenes. So let's start. See the first one. The question is, which of the following alkene is treated with HCl yields majorly an anti-Markovnikov product? Now let's see the reaction at first. We know when this kind of molecule, this is unsymmetrical alkene, is treated with HCl, the reaction will proceed via formation of the stable carbocation. Why this kind of carbocation has been formed? Because it is 2 degree. But though it is 2 degree, it depends on the nature of the R group as well. It depends on the nature of the R group. If R group is alkyl or any kind of electron donating group, then this 2 degree carbocation will be highly stable. Now let's see here the provided R groups are what? In the first option it is Cl, second option it is NH2, in third option it is CH3O, that is methoxy, and in fourth option it is CF3. Now Cl having minus I effect as well as plus R effect little bit. NH2 also same, minus I as well as plus R. CH3 minus I plus R. But CF3 having strong minus I effect. So that means in the presence of Cl, NH2 or methoxy group, this 2 degree carbocation can be stabilized. But when the R group is CF3, then this kind of 2 degree carbocation would never be stable. Then what kind of carbocation will be formed in that case? So in that case, CF3, CH double bond CH2, it will lead us to the comparatively more stable 1 degree carbocation. And ultimately Cl minus will be added at the terminal position. So this is nothing but the anti-Markovnikov product, because according to Markovnikov rule, the negative part of the reagent should be added to that carbon where, to that carbon containing double bond containing carbon where the minimum amount of hydrogens are present. That is Markovnikov rule. But though here no peroxide, no photochemical condition is applied, still anti-Markovnikov product is obtained because of the presence of CF3 group. Okay, so here the correct option will be option 4. Okay, next, move to the next one. Increasing rate of SN1 reaction in the following compounds. These molecules are nothing but I. All molecules are I, all atoms here are I. And we have been provided these 4 molecules. We have to compare their rate. Now see, at first, let's see the carbocation which will be formed from these molecules, what will be there. See, the general structure is this one. General structure. Now, when carbocation will be formed, this I will be removed and we will get this molecule. This is the carbocation. Now, this carbocation will be stabilized by the groups present in the benzene ring or aromatic ring. Now, which groups are present and which position they are, that is important. For the first option, option A, there is no group. That means all hydrogens are present. In option B, there is OCH3 group, but it is present with respect to this group at the meta position. So this group is present at meta position. This CH3 is present with respect to this position, that is para position. And this OCH3 also present at the para position. Now let's see what kind of effects they have. We know OCH3 having plus R and minus I. CH3 having plus I and hyperconjugation. Okay. Now, when OCH3 or CH3 are present at the para position, they can show plus R effect as well as hyperconjugation respectively. But in case of meta position, OCH3 cannot show any kind of mesomeric or plus R effect, but it can show minus I effect. Due to minus I effect, the stability of the carbocation will decrease. So obviously this molecule, this B molecule will have minimum rate in SN1 reaction. So increasing order is asked. So the B will be the last one. Next, which one? Next, CH3 and OCH3 both having electron donating effect. OCH3 having plus M or mesomeric effect, and CH3 having plus hyperconjugation effect. So A will be then, because A contain only hydrogen. Between hyperconjugation and mesomeric effect, which one is more powerful? Obviously mesomeric effect. So third position will be of C, and the last one is for D. So that will be the condition, that will be the increasing order for the SN1 reaction. Now let's see where this option is present. BACD, BACD, option B. Option B is the correct answer. Now next, move to the next one. Very good question. See, the major product in the following reaction. Very, very important. And in the classes we have discussed also this kind of questions. See what will happen. Since this reaction is proceeded in methyl alcohol, that is nothing but solvolysis reaction, and solvolysis reaction go via SN1 pathway. And in SN1 pathway, carbocation will be formed. So at first, CBr bond will be broken. So what we will get? We will get CH3. Now see, this carbocation is 2-degree carbocation. Now this carbocation will try to become much more stable, and it will search for this kind of stabilization. How can it be achieved? It can be achieved by the methyl shifting. If this methyl has been shifted, what we will get? We will get this carbocation, and this is 3-degree carbocation. And as we know, 3-degree carbocation is more stable than 2-degree. So this is the stable carbocation. Now the solvent, that is methyl alcohol CH3OH, will attack at this position, and minus H plus, we will get the product. Product will be CH3, OCH3. CH3. That will be the product. Let's see, is there any option? Such kind of option is present. Is it present? CH3. Here it will be printing mistake probably. It will be 6-3. That will be the correct option. Okay. Next. See, it is also very good question. This kind of question has been discussed in class 11 as well. When this unsymmetrical alkene is given, and at first chlorination is done. So cyclic chloronium ion will be formed at first. But since Cl is comparatively more electronegative, positive charge on Cl atom is unlikely. So one CCl bond will be broken. Now which CCl bond will be broken? That CCl bond will be broken which can produce more stable carbocation. See, if this bond has been broken, we will get CH3, CH plus, CH2, Cl. Now it is 2-degree carbocation. Next, in medium, water is present. So water will attack. Minus H plus. What we will get? We will get CH3, CHOH, CH2. Okay. So CH3, CHOH, CH2 option. Move to another one. Here, at first, HBr will be added to the alkene. So let's see what will happen. At first, HBr will be added. So what we will get? We will get this. Now, beta hydrogens will be eliminated because alcoholic KOH is there. So OH minus will abstract the proton and elimination reaction will occur. So what will happen? It will abstract this proton. Similarly, here also. Similarly, here also. Now, the interesting thing is that why the alpha hydrogen of the carbonyl also been eliminated, because if it has been eliminated, the ring becomes aromatic. So for extra stabilization, this alpha hydrogen has been also abstracted by the base. If there is no possibility of aromatization, then this hydrogen will not be abstracted. So in the next step, in presence of water, it is converted to ultimately phenol. So this is the product. So here also. Now come to another one. See, here elimination reaction will occur. Elimination reaction. And basically it is E2, elimination bimolecular. And as we know, in elimination bimolecular, the main factor is anti-elimination. Anti-elimination is important. So anti-elimination will lead us to which product we have to see. Let's start. Now, this Cl is above the plane, so the beta hydrogen should be below the plane. Beta hydrogen from this CH3 will not be possible because this CH3 and this Cl are on the same plane. In this carbon, this is beta carbon, but there is no hydrogen, so no beta hydrogen there. But here, this beta carbon contain beta hydrogen, and moreover, this beta hydrogen is below the plane. So this hydrogen and this Cl are anti-periplanar to each other. So it will be abstracted. So OET minus will abstract this proton and we will get CH3, CH, double bond C, CH3, COO, CH2. That means CH3 CH, double bond C CH3, COO, CH2 CH3. Let's see this kind of option. Yes. Option. Okay, understood. Next. Elimination reaction of 2-bromopentane, it will be 4. It will be 4. 2-bromopentane. It will be 4. Not from. 2-bromopentane. From there we were getting pent to in. This is pent to in. Now, how this reaction will proceed? In presence of base, the beta hydrogen will be abstracted. So it is basically elimination bimolecular reaction, E2 reaction. First point. Second point, the product is Serge product, and here dehydrohalogenation will occur. Dehydrohalogenation. So the among these given option, elimination applicable, Serge rule applicable, dehydrohalogenation applicable. Dehydration, no dehydration is occurring there. So 1, 2, and 3 options. That is the correct answer. As we already discussed in classes, that if Br, I, etc. groups are present, it will undergo Serge elimination. So Serge product is obtained. Okay. Next. Major product in this reaction. Let's see how can we handle this. Potassium tertiary butoxide. So at first elimination will occur. This is beta hydrogen with respect to this Cl. So tertiary butoxide, the base, will abstract this proton and we will get this molecule at first. Okay. Next, in the next step, constant H2SO4, that is H plus. H plus will protonate this double bond. And what will happen? We will get a carbocation. Now the question is, carbocation will form at which position? It can be formed at this position or at this position. Now which position will be preferred? Obviously carbocation will be formed at the terminal position. Though it is 1 degree, but still it will be formed because this is electron withdrawing group. If 2 degree carbocation is formed, that will be unstable. And then what will happen? Then annulation will occur. Annulation means ring closing. Let's see what will happen there. On the next step, rearomatization. So we will get ultimately this. So this kind of molecule will be formed. This molecule. Okay. This is very simple question. C6H5. Okay. Now, in presence of potassium tertiary butoxide, the beta hydrogen, which is anti-periplanar to the Br, will be abstracted. And we will get this molecule. This is trans stereoisomer, and the name of this molecule is stilbene. So here the option is given simple stilbene only. If it is given cis-stilbene or trans-stilbene, the major product will be trans-stilbene. Okay. Next. This is very good question. This reaction goes via benzyne intermediate. Let's see how it will proceed. This reaction. Hydrogen, which is flanked between two electron withdrawing group, will be abstracted first by the strong base sodamide, that is NH2 minus. And this beer will be eliminated. So what we will get? We will get this kind of intermediate, which is known as benzyne. Now, on the next step, NH2 minus will again attack. Now the question is, at which position this NH2 minus will attack? It will attack at that position which will lead to stable carbon ion. If it is attacked at this position, the negative charge will form at this position, that is this will form. And if this will form, this negative charge can be stabilized by the minus I effect of OCH3. Minus I effect of OCH3, this negative charge can be stabilized. Okay. Here, this kind of benzyne intermediate related reactions the mesomeric effect or resonance effect will not at all operate. Only inductive effects are operating, plus I or minus I. The reason is discussed elaborately in the classes. So see here what will happen. After that, from ammonia, it will abstract proton, and then we will get this kind of product. So here, at which position Br was present, it has been substituted by NH2. So the correct option will be, this is the product and this substitution reaction. So this kind of reaction goes via benzyne intermediate, mind it. Last one. Which reaction proceeds through an electrophilic substitution? Very simple. The first one. The answer will be the first one. Why? Let's see. At first, chlorine on reaction with anhydrous AlCl3 will produce this kind of species, that is Cl plus and AlCl4 minus. This Cl plus will act as electrophile. When it is treated with benzene, at first this kind of sigma complex being formed, which is known as Weyland intermediate. Then rearomatization will occur and we will get this chlorine. This sigma complex can be stabilized by the resonance. You can see this sigma complex is stable because of the resonance in the ring structure. Okay. So the correct option is formation of chlorobenzene by the reaction of benzene and chlorine in presence of anhydrous AlCl3. Okay. Thank you.